Django is an extremely popular Python framework, probably the most popular one. Developers love Django because it lets them create web applications really quickly. But you can go even faster when you start developing your Django applications in PyCharm. In this tutorial, we will create a very basic Django application. The app shows the air temperature at your location. If you are not happy with that, you can check the weather in other random places. Not too many features, you can call it a demo rather than a full-fledged application, but it works just like most real apps do. It reads from the database, makes API requests, processes responses, and displays, well, kind of, useful information in the UI. When you work in PyCharm, every new project starts with creating a new project. Let's do that. Click New Project on the welcome screen and select Django in the left pane. Django support is available in the Professional edition of PyCharm. If you don't have a professional license, you can use the 30-day trial period. If you are a student or a teacher, you can also apply for a free educational license. The name of the project is actually the folder name, which I need to type in the location field. Then I need to specify the Python interpreter for my project. That can be a virtual env, pip env, poetry, or conda environment. You can also select a previously configured interpreter, if you have any. In this tutorial, I will use virtual env. Finally, I expand more settings and give a name to our future weather application. Now I am ready to click Create. PyCharm installs Django and other dependencies, creates the file structure, and so on. Let's launch the Django server. I click the Run icon at the top. Now the Django server is running. Click the link to open it in the browser. So, it took us roughly a couple of minutes to get the Django server running. In the previous part, we've created a Django project and launched the Django server for the first time. Thanks to PyCharm's Django support, that part was really quick and easy. Now let's write some code. In this tutorial, I will use shortcuts for quick access to project files. If you prefer to explore the file structure visually, here is the Project Tool window, where you can find the project tree. By the way, I'm using PyCharm's new user interface now. To turn it on, open PyCharm Settings, then go to Appearance and Behavior, and select New UI. Let's create the application logic. In Django, that's done by writing functions or classes in views.py. I press Shift twice to open Search Everywhere and type Views. Here it is. The first feature of our application is to show the temperature in the current location. Let's write a function for that. I'll call it temp here. The function will send requests to the Weather Forecast API. It's a free API that doesn't require an API key. Here is its endpoint. To make a request, we also need to send the coordinates of the current location. Let's use the geocoder library for that. Geocoder is highlighted with a red squiggly line. It means that this package needs to be installed in the project virtual environment and imported in views.py. I press Option plus Enter to see the available quick fixes. If you are using Windows or Linux, press Alt plus Enter. Then I select Install and Import Package Geocoder, which is exactly what I need to do. We will use our IP to obtain the coordinates, namely the latitude and the longitude. Let's write the API request. You'll find a link to the Weather Forecast API documentation below. First of all, I need the endpoint. Then, we'll pass the latitude stored as the first item in location, and the longitude, which is the second item there. We are requesting the hourly forecast of the air temperature near the ground surface. The function will return the response to the API request. We need to import the requests module first. It's a GET request, which is stored in the variable, and we need it in the JSON form. Let's make sure that this function actually does what it was written for. The easiest way to achieve this is to run it in the Python console. If you are looking for a specific action in PyCharm, you can avoid unnecessary mousing and clicking by using the Find Action window. To open Find Action, press Shift-Command-A or Ctrl-Shift-A, depending on your operating system. If you don't want to memorize another hotkey, just press Shift twice and then keep pressing Tab until you are on the Actions tab. You don't need to type out the whole command here. Instead, you can use kind of camel case without capital letters. For example, if you type ru-py, you'll get run file in Python console. To invoke the action, just press Enter. PyCharm opens the Python console and loads the contents of views.py, including the imports and the function definition. Let's call the temp here function. You can press Tab for code completion here. We need to examine the API response. It's a very long string, so let's transform it into something more readable. Triple-click the output and then copy the string into the clipboard. Create a Scratch file by pressing Shift-Command-N on Mac or Ctrl-Alt-Shift Insert on Linux and Windows. Select JSON as the file type. Insert the API response from the clipboard. To make this more readable, we need to apply the Reformat Code action. I'll use Find Action for that. I press Shift twice. In fact, this is the only shortcut that you need to memorize. Then I tab into Actions and type the first letters of Reformat Code. You see that we have a lot of errors in this file. Let's fix them. Click the widget to open the Problems tool window. Nearly all errors are about single-quoted strings, which is not allowed in JSON. Right-click on error. Select Show Quick Fixes. Click the kebab and select Fix All Problems in File. Now everything looks fine, and we can inspect the response from the Weather API. Here are the coordinates that we've sent in our request. Time contains the hourly timestamps for 7 days starting from 0 a.m. today. The temperature data is contained in the list under the temperature_2m key. To get the current temperature, we must pass the current hour as the index. For example, if it's 14:30 now, we'll take the item with the index 14. I'll go back to the Python console. Now I'll invoke the temp here function again. This time, I don't need the whole response. All I need to know is the current temperature at my location. So I need hourly, and in hourly I need temperature_2m. But only the element at the index 14, because it's 14:30 now. Then I press Enter. 9.1 degrees Celsius is currently outside in my location. The temp here function needs to be modified so that it returns only the current temperature and nothing else. Let's go back to views. I'll use Command-E for recent files on my Mac. You can use Ctrl-E if you are on Windows or Linux. First of all, the function needs to know what time is it now. Don't forget to import date time. We need only the hour. Let's introduce the metadata variable for storing the API response. I open Find Action and type int var, push Enter, and type the name of the variable. Then I repeat the same steps to introduce temp that will store the current temperature. Let's reuse our previous request from the Python console to extract the required data. Let's make sure that the function works as it should. I reload the updated function definition into the Python console by clicking Rerun here and invoke temp here once again. I get the same result, 9.1 degrees, which means that the function works correctly. If your result is not similar to the previous one, this is likely caused by the wrong time zone setting in Django's settings.py. Press Shift twice and then use Tab for switching to symbols. Type time, and here it is. Make sure that this value is your time zone. Now we have a working function which returns the current temperature. But it's not a view function. To be recognized by Django as a view, a function must accept an HTTP request object as its first parameter, which is typically named request. And it should return an HTTP response object. I type htrs, hold Ctrl, and press space twice for autocompletion. Pressing space twice instead of once gives me suggestions for functions which haven't been imported in the current file yet. I select HTTP response and it's added to the list of inputs automatically. Finally, let's specify a string for the HTTP response. When I insert a variable into the string, PyCharm provides me with completion options and converts the string into an F string. We have created the application logic in views.py. In order to see how the app works in the browser, I need to configure URLs in urls.py. Let's open the project tool window. There is urls.py in the project directory. It has been created during the project setup. Let's open it. Django projects often contain more than one app. Even if that's not currently the case, we should consider the future development of the project. That's why it's a good practice to create urls.py for each application. I will include the contents of urls.py of the Meteor application into the project's urls.py. The yellow squiggly line here means that there is no urls.py in the directory of the Meteor app. Let's fix it. Right-click the Meteor directory in the project tool window, create a new Python file, and name it urls. Let's specify the URL that will call the temp here view function and show whatever it returns. I import path from Django URLs, and here is the address of my app. The temp here function is in views, and we need to import it. Remove the parentheses as we don't need them here. Finally, specify the name of the view. Now let's rerun the Django server to see the result. Open the browser. Oops, but that's okay, we need to go to Meteor. This is how my app works for now, and I'm pretty happy with that. By the way, these are Celsius degrees. If you prefer Fahrenheit, you can achieve that by slightly modifying the API request. Let's check the result. It works, but I find it very annoying that I have to add Meteor to the URL manually every time when I restart the Django server. To avoid this, I will edit the run configuration. I select Edit Configurations in the Run widget. This is my Django configuration. I want to open the browser automatically and with the right URL. And now, when I click Rerun and confirm the action, the browser opens automatically and I don't have to type anything in the address bar. Now we have a working app that shows the temperature at the current location. But it's just plain text, which doesn't look very nice. Let's work on that. I'll create a template. Django templates define how the information is displayed in the browser window. I press Option plus Enter and choose to import loader from Django template loader. Then I apply the getTemplate method and specify index.html as the template file. To pass the data into the template, we use context, which is basically a dictionary with variables and their values. For now, the context contains only the current temperature, temp. Finally, I'll modify the return statement to get the rendered template instead of the text string. Index.html is now highlighted with a yellow squiggly line. That's because it doesn't exist. Let's create it. The template is empty for now, but PyCharm can fill it with some useful content in no time. I type html:5 and press Tab. This feature is called Live Templates. The visible content should be located between the body text. As you can see, I continue to use Live Templates. I type the required tag without angle brackets and then press Tab. This is how I get a pair of HTML tags. Here goes the current temperature from the context. And this one is the Unicode representation of the Fahrenheit degrees symbol. Let's rerun the Django server and see what it looks like now. The API that we are using in our app provides us with temperature data in response to coordinates. To show temperatures in random cities, we need a database with cities and their coordinates. Let's use the World Cities database from Kaggle. You'll find the link below. Download the database and extract the CSV file from the archive. If you don't have an account at Kaggle, you'll need to create one. In the Project Tool window, you can see the DB SQLite3 database, which was automatically created by Django. I need to open the Database Tool window. That can be done either by clicking the database icon on the right or through the Command E menu. If you are on Windows, it's Ctrl E for you. In the Database Tool window, I click the plus icon and select Data Source. Then I type SQ and choose SQLite. Now I need to browse for the database file in my project. If PyCharm warns you about missing drivers, click Download. Let's test the connection to make sure that everything is okay. Nice. Now we need to import the data from the downloaded table into the database. Just drag and drop the CSV file from your Downloads folder. I remove the unnecessary fields, keeping only city, latitude, longitude, country, and ID. Now I have the World Cities table in my database. And I can easily explore the contents. In the previous video, we've imported the database into the project. Now I want to use that data in my application. To be able to, I must create a model. We already have models.py in the directory of the Meteor application. For now, it's empty, and normally you should write some code here. But I want to show you a trick. We already have data in our database. So let's generate a model based on this data. Press Option R on Mac or Ctrl Alt R on Windows. A console opens. This console lets you send commands to Django's manage.py utility. You can use it to manage applications, databases, and otherwise configure the project. Now I'll type the inspect.db command. There is completion. Press Enter to apply suggestions. Then I need to specify the table name, which is World Cities. Finally, I press Enter to run the command. The manage.py utility has generated the World Cities class, which is actually a model that we need. I'll copy it to models.py. A model should have at least one primary key. Let it be ID. Let's see why we have a yellow line here. It's because we need two blank lines after imports. Now that I have the model ready, I can use it in the application logic to retrieve the data from the database. I switch to views.py. By the way, there is an unused import at the top. Let's remove it as suggested by PyCharm. For now, we have only one function that shows the temperature at the current location. To show weather in random locations, we need to write another function. The function will work in a similar way, by getting the current temperature from the Weather API. I select and move the line where the coordinates are saved in the location variable based on the IP address. It's only needed for the current location. In another function that will be created later, we will use the coordinates of randomly selected cities. Now these lines need to become a separate function. I press Command-Option-M. If you are on Windows, press Ctrl-Alt-M and specify the name of the function. Let it be getTemp. Now we have the getTemp function. It accepts location as the sole parameter and returns the current temperature in that location. Temp here calls getTemp, passing the coordinates of the current location to obtain the temperature. Before writing the next function, let's do some prototyping in the Python console. First of all, we need to obtain the coordinates of cities from the project's database. And that's when we need the World Cities model from models.py. Let's import it. Let's pick a random city with its coordinates from the database. We'll take all table records Then randomize them and select the first item. Hit Enter to run the code. On the right side of the Python console, there is the Variables tab. Let's see what's there in random item. We have San Marcos and its coordinates. Cool. Let's create the function. I'll name it temp somewhere. Like any view function, it accepts request as its first parameter. Let's copy the random item assignment from the Python console into the body of the function. And the import of the world cities model to the beginning of views.py. We'll need the name of the randomly selected city and its coordinates. To know the temperature, we'll send the coordinates to getTemp. I'll copy the rest from temp here to save time and provide a more detailed context to show the city name on the page. As the context now contains a city name, we need to edit the template as well. Here is the gutter icon for quick access to index.html. The city name needs to be displayed here. But temp here doesn't provide a city name. Let's do something with it. Here is another gutter icon. I choose temp here. Let this function pass your location string instead of the city name. We also need to configure the way how the newly created view function will be accessed from the browser. Let's go to urls.py of the Meteor app. Temp here is called when we open server address /meteor. Let's call the new function when we open server address /meteor/discover. Now that we've configured the URLs, I can add links to the template to have navigation. I'm adding the link for showing weather in random cities. Here goes the name that we specified in urls.py and the link to the home page. Finally, let's rerun the server and see how it works. Congratulations on creating the Django app. We've managed to implement the third-party API and added a feature just as we planned in the beginning of this tutorial. But there is always space for improvements. First of all, the app looks ugly, let's admit that. There is a simple way to tweak almost any basic web application easily. It's called SimpleCSS. You'll find the link below. I go to Docs, Getting Started, and here is the line we need to copy. Then I go back to index.html in PyCharm and paste the line between the head tags. Let's check it out. Looks way better now. Below this video, there is a link to the text version of this tutorial, in which you'll find code for further improvements. For example, you can use buttons instead of links, or even implement Bootstrap. That's how you can create a Django app in PyCharm Professional. I hope you followed all the steps and now have a working app too. Along the way, we've learned a couple of other things like creating a Django project in PyCharm, prototyping Python functions in the Python console, importing CSV data into the database, and so on. I hope you'll find them useful.